So good day everyone. Today we'll be discussing about the encoder, and we are provided with its truth table with three outputs x, y, and z, and we are tasked to solve for its schema and create its schematic diagram for in Proteus. So first, in finding out how to create its schematic diagram, we first need to solve for its schema. So here's an example of my solved schema for the value of x. So for our convenience, we'll be using these inputs for the schema. So A, B, C, D for one set and E, F, G, H for the other. So if you're wondering how to find out these values to correlate their Boolean value, so we need to generate these things which are called gray codes. So in generating a gray code, first you need to write 0, 1 in a column, draw a mirror under that column and reflect the numbers above below. So here in this example, 0, 1, then you put a mirror under those set of numbers and then reflect those numbers below that mirror. And then for a 2-bit gray code, you will need to continue the process until you achieve your desired inputs for the K-map. So now we will now correlate which of the outputs correlates their inputs. So for example, 0, 0, 0, 0 and 0, 0, 0, 1 correlate to an input in X. So we have an open cell here, and we do that for the rest of the value outputs for each of the outputs. So we have these outputs for output X, and then these are for output Y, and these are for output Z. Now to find its Boolean equation, we just need to correspond each letter of input to its Boolean value. So for example, in this output, so we have not A, not B, not C, and not D, not E, not F, not G, and H. So we have these, and we just repeat it for the rest of the outputs. So for X, we have this equation, which can be simplified into this next equation, which is X is equal to not A, not B, not C, not D, or times not E, not F, not G, H, plus not E, not F, G, not H, plus not E, F, not G, not H, plus E, not F, not G, and not H. So we will be using this equation in finding out the schematic diagram for this activity. So this is for Y, and this is for Z. So now, once we get all of these three equations, we will now proceed to Proteus. So this is the solved schematics for the activity. So as you can see, I have color coded the wires for each of the outputs. So in this first set, you will see this is the equation for output X, the one in gold. The pink ones are the wires connected to the output Y, which corresponds to its Boolean equation, and also to output Z. So as you can see, we will do it side by side. If we what you call this, start these schematics, you will see that if only the input is B, you will see that its output is only Z, which makes our truth table, our K-map Boolean equation, right? And if only C is is the only input, you will have only y. If D is the only input, you will have both y and z. If E is the only input, you will have only x. If F is the only input, you will have only z. If G is the only if you have F as your input only, you have x and z. If you have only G, you will have x and y. And if H is the only input, you will have all of them lighting up. So as you can see that all of these outputs correspond to each of these inputs, which makes our K-map and Boolean equation correct. And that is how you do the schematic diagram if you are given a truth table. So that is all, and thank you for listening.